So Hadoop, everybody, big industry term, big new way to store data. All the back end in terms of the way the data is stored is very different. But what the analyst sees, and I'm showing you one of the views now for one of the main kind of paid options for Hadoop, is, to be honest, not that much different than what you've seen in traditional database systems. Well, again, the data is organized different. The way we query it is actually, it's just a variation. It's essentially just a SQL type commands. What you're seeing here is the query view where you have the databases you can choose from on the left. You have the actual SQL here. I mean, I can type something simple like this, where ... and really that's all that you're seeing. I mean, it's, from the analyst view, it's not that much different than what we've seen in the past. We have our output window on the bottom. And if I run this, in the past we would say something like top 5. That doesn't exist now. We say something like limit 5. When I fire it up, it's usually not that fast, but as you can see, it's just like you would see in a normal database window. Now, what's different, though? There are some differences here that we need to keep in mind for the way this stuff's organized. One of the big ones is dates are actually treated a lot different. While this looks like a date timestamp, it's actually a text field. So if you've used SQL in the past and you have all these great date calculations, it's a little bit different because dates are treated as text. One of the other really big differences is there's things called complex data types. So what I mean by that is, let me just comment this out. You have a lot of key value pairs here. So what I mean by, I'll show you what I mean in a minute. So in the old school database world, lots of times you have everything is in its own column, and nice and clean. Everything's in a nice column-based fashion. In the world of big data, a lot of times they shove everything into key value pairs, meaning this value and that, all in one big cell or in one field. When this fires up, you'll see in a minute. Hadoop's going to work in the back end. It's doing all their mapping and reducing mean. It's taking that distributed system, and it's pulling it all back for me right now. So right here, you're seeing a good example of one of those complex data types, meaning it's a big list of keys. In this case, the key is action code, and the value is the specific thing that you've identified. This is just one actual field. So that makes things a little bit different because you have to query it a little bit different, but it's the same basic concept as before where you just use SQL to essentially get at this. So that's the basic of the interface. One of the cool things you can do is I can actually go into Tableau. There's actually a place for Cloudera Hadoop. I can actually go in and treat it like I would a normal data source. So here we go. I mean, it feels like a similar data source for, if you've ever used Hadoop, and if you've ever used, not Hadoop, if you've ever used, hold on, Tableau in the past and brought it and hit a traditional database or hit Excel, it's the same basic concept. I mean, it's just slightly different interface. Everything really feels the same as when I can actually bring this in and look at it. I mean, it connects pretty clean, so you can actually publish Tableau directly from Hadoop. So I realize I don't have too much time here, but some of the other fun things that happen is fun and not so fun things that happen in this type of interfaces. If you built a lot more custom and use a lot more advanced functions, those have not made it over into the whole Hadoop world yet. So if you've done a lot of really complex cleaning, complex analysis, a lot of those really amazing functions, the SQL used here is pretty stripped down. The one good thing, though, is if you've ever used regular expressions, those actually can be used on top of Hadoop, which makes life pretty easy for a lot of complex text string searching and replacements and all that sort of fun stuff. I'll stop here. I mean, if there's any other questions, I mean, I can keep going, but
I
are there
have
any
a couple,
questions you had?
well, I have a couple and before anybody else starts going, well, so as people start typing, but here's my quick question is this, you had mentioned that Cloudera is, they give stuff away for free and then they sell their services. Is what you're showing us something that I could theoretically download right now and start using, or do I have to pay for this?
I think you can use it for, maybe not from Cloudera specifically, but I have seen almost an identical interface for their big competitor called Hortonworks. And my understanding is you can go in and actually start to create your own type of thing like this now if you wanted to on a smaller data set.
Do they let me put, if I was using Hortonworks, obviously I don't have a Hadoop cluster in my basement. Does Hortonworks, would they let me, do they somehow host something for free for me, or do I have to pay for that, or what?
I don't know. That's a good question.
Okay. So I've stumped the master. This is fascinating. I didn't know you could use SQL to get into Hadoop. I know very little about Hadoop, but you've got some people on the chat board here. I'll read the questions for the people listening to this recording at a later date. But let's see. We have Vib Horbata, and he says this is a Hive interface which abstracts HDFS complexity by giving us a SQL interface. Don't know what the heck that means, but it sounds important.
Yeah. So what that means is, yeah. So the way Hadoop was built originally was in a framework called MapReduce, which basically distributes and then grabs it from them. It's built on a Java architecture, and what Hive does, it takes SQL like this, translate it into that crazy Java-based language called MapReduce, and then it hits the cluster. So really, even though I have a SQL interface, SQL is not the native language actually on the system. Hive is just like it's a Hadoop-like SQL.
Okay. Wow, listen to this. Vib Horbata is an expert in this too. He says you could use Spark, Python, Java, SQL, anything to access HDFS data. So Vib Horbata, can you? We could put Python code up there where Jason's putting his SQL code, and that would theoretically work.
Before here, again, I'm on the phone today. So, Jason, you want to answer that, or I can?
Sure. So everything turns into MapReduce. I mean, keep me honest. Everything turns into MapReduce, but you can install driver like a Python driver or these other drivers. Even like you can deploy R across the cluster. You have these translators built in. So you hit the Hadoop cluster with these different languages, like you mentioned, but ultimately gets translated into MapReduce as it ultimately touches the cluster close to the data.
So MapReduce is its own language then?
I think so. So keep me on. The other person, I forget your name, but I want to say yes, but not completely.
So MapReduce is a framework. Basically, what it does is it does the translation of your application, whether it's written in SQL, whether it's written in Java or whatever language, but then it kind of translates it into a form which kind of collects data from many different clusters in which your data is split into. So mapping is the process of kind of taking your commands and breaking them down so that it is sent to those individual clusters. And the reducing part is when everything is collected back together. So if you're like doing a sum over like data which is sitting in 3 different clusters, so mapping is the part of sending those queries down. And then reducing is to collect that individual responses from individual clusters and then sending you a collected sum of your whatever query you're writing. So that's the framework of mapping and reducing, which is written in Java, as Jason is saying. But then for an application developer like you and I who know R or Python or I don't know if SAS does it, but so these interfaces like Hive allow you to do it in an easier interface which people like us can work with it. So the complexity of Hadoop and MapReduce and everything is kind of abstracted from us using these Hive-like interfaces.
Oh, well, this is very interesting. I'd like to know more about Hadoop, so maybe as a thought for going forward, the next time we do a show and tell later this quarter, if anybody wants to hop in and do more talk on Hadoop, that would be really welcome. Jason, we're running up out of time here. Is there any other final things you wanted to say? And if there's any slides you can email to me, that would be wonderful. Or I think it looks like somebody here, you could do some kind of a file share, but emailing them to me would be useful as well.
Sure. So here's from some of your colleagues. So they actually presented to us on how different methods to connect SAS into Hadoop as well.
Oh, wow. So you could write SAS code to access Hadoop?
You can. There's basically a driver or transit in between. So you write native SAS code with some variations, and then it translates that in the MapReduce framework, like you would with Python or Hive or the Hive SQL. There's different things that the other person mentioned. I can email you this though.
Oh, that's fascinating. And anything you send us, and I'll post it out there on the websites or the classroom boards for the various classes. Anybody else have any final questions? Because we got to move on to the next person. So while Viprabhata is typing, who wants to be the next person? And I'll make you presenter.
This is Scott. I can go.
Okay. Well, I think John Fakula volunteered first, but John, you could be next. How about that? Oh, John, that's you, right? Sorry. John, I'm going to make you the next guy. Jason, thank you very much.
No problem.
Did everybody hear me? This is John Fakula.
Yep, we can hear you now.
Let me share my screen here.
John, tell everybody what you're talking about.
Okay. My discussion today is going to be about explaining how Google, when you do a Google search, you see ads on the right-hand side, exactly how Google determines the position of those ads, which is a little more involved than you might think on the outset here. Let me open up the PowerPoint here. Okay, can everybody see the first slide?
Oh, we can now.
Okay. All right. So basically, my topic is going to be, we've all gone to Google before, and you type something, you type a query into the Google search box, and you're going to get what they call the organic side, which is on the left-hand side. That is Google's proprietary algorithm that determines what links are on that side. As an advertiser, you don't have any say. You can't pay to play on that side. You have to earn your way on that side. On the right-hand side are the sponsored links, or ads as they call them. And here's an example of the typical Google screenshot that I'm sure we're all familiar with. But just to get some vocabulary down, that'll make it easier to explain exactly how these ads are positioned. You have ads on the right. You typically had purely organic results on the left, but increasingly Google is putting more and more ads on the left as well. And then you'll see in the middle there is just a shameless plug to my own company that, just for the sake of an example here. And a query string, or search query is what people are typing in Google. Okay. And every time I've had this discussion with people, they always claim that they never ever click on the right-hand side because they know those are ads and are not as relevant to them as the left-hand side. But that is almost surely a mistake, and that almost everybody does that because just in 2014 alone, Google made a little bit over $59 billion just on those ads alone, and you can see some shocked monkeys there to look at that statistic. Basically what happens is that for every ad that's clicked, Google makes money. Google does not make any money per impression. They only make money when somebody actually clicks on that link. which is good for the seller as well, because that way, instead of paying by the impression, we're actually paying for results when somebody actually clicks on our ad and goes to our website. So how typical most auctions work, the definition of a bid here, and when I say bid, it's a little bit different than a typical bid where you're just paying per click, because what you have to do when you're running an ad campaign for Google is that you need to create an ad, and then you also need to create a list of keywords, probably about 20 keywords up to 100 keywords, that depending on how closely the Google user types in their search query, if that search query is a close result or an exact match to the keyword, that would trigger your ad to be shown. What most people believe is that it's just a pay-to-play, and whoever spends the most money gets the first position in this slide here, seller A. If they're willing to pay $1 per click, they're in the first position. Seller B, a little bit less, for 75 cents, they get second. And seller C pays only 70 cents a click, gets third. But that is very much not the way Google does it, because Google will also reward the quality of your, they'll assign you something called a quality score that we'll dig a little deeper into. And your rank is actually determined not by just how much you're willing to pay, but also what your quality score is. Those factors combined is what determines the order of the ad. And just very brief, high level, when you're creating an ad for Google, you have 3 lines to work with. Your first line is your title line, and you're limited to an absolute maximum of 25 characters. Your second and your third line have a maximum of 35 characters, and the landing page URL, i.e. where the link goes when somebody actually clicks your ad, that could be any length, because you could add URL parameters to track various things. Once you create your ad, you create your list of keywords that you want your ad to appear for, and keyword is nothing more than a list of keywords or phrases that if somebody types that into Google, you want your ad to show for that result. And then you set your pricing that you're willing to pay per click. So you might, for example, this is an example of one of our actual ads here. And then the 5 of the roughly 50 keywords we have for that ad. So this ad could show, 1,000 times, and if people click it 10 times, then we only pay for what we're willing to pay for that keyword, the 10 times, and not per impression. So ultimately, what Google does is a combination of both the bid and quality score to determine the position. The quality score is an integer score from 1 to 10 that Google, using numerous factors and predictive models and historic data, will assign for each and every keyword you list that's connected to your ad. And this is at the heart of the complexity and where it gets tricky for advertisers to advertise on Google, because you want your quality score to be as high as possible, which we'll see in the next slide exactly why. There are 6 key factors that make up this quality score. The single most important factor in this is the click-through rate, i.e. what percentage of the time when your ad is shown is your ad actually clicked on. This metric is highly important for Google because obviously they don't make money unless somebody clicks, so they want that click-through rate as high as possible. And so does the seller, because the more people click on it, the more eyeballs get to your website and the more you sell. And just as an FYI, Google will consider a click-through rate of 1% as excellent. Anything above 1% will put you probably in the top 5 percentile at least. The next important factor of this quality score is something called ad relevancy. Google will not only analyze your ad, they'll analyze your keywords that you selected, and they'll analyze how closely your keywords match what the user is searching for. And they want your ad to be as relevant as possible because they want the users to have a good experience. So if your advertisement is about Christmas ornaments and you pick a keyword, of hot dog, then that will produce an extremely low quality score because, if people are searching for hot dogs when they see an ad for Christmas ornaments, nobody's going to click it, and Google will actually penalize you for that. They also take into consideration your landing page, the page that actually, when somebody clicks on the ad it goes to. They analyze your landing page and determine how relevant it is to your ad, how relevant your ad is to the keywords, and how relevant your keywords are to the actual search queries in this kind of round robin of relevancy that Google does. And keyword relevancy, overall account performance is somewhat of a factor, just how well your overall Google account and advertising does, as well as your targeted ad performance. Google will let the seller target particular demographics. Google will actually make an educated guess based on predictive analytics as well as history, whether the user is a female or male, what rough age range they're in, whether they're a parent or not, and they obviously have like the geographical information of where that person's coming from. So they might give you a high quality score for a female that's 35 to 40, but a low quality score for a male that is 7 years old or older. So ultimately, Google uses something called ad rank to determine the formula for exactly how ads are positioned when you go to the Google page. And the formula reduces down to a very simple ad rank is how much you're willing to pay times your quality score. And that belies the real complexity, which is in the quality score itself. That quality score is updated every single time you add a keyword, and it's also updated every 24 hours for every keyword, for every ad, for every advertiser in the Google network. So we'll take the same chart that we saw before that was based purely on how much a person was willing to bid, and you can see by when you factor in the quality score how much of a big difference that makes, because now all of a sudden seller C that was only paying 70 cents, or that is only paying 70 cents a click, because their quality score is 9, you take the 70 times 9 and you get what is called an ad rank bid or ad rank score of 6.3, and that actually puts them in the very first position. Seller B, the one that was only willing to spend 75 cents, all of a sudden they're in position 2, and seller A, who is willing to spend a lot of money relative to the others, $1 a click, but has a bad quality score, he ends up in a kind of a distant third as far as the ad positions go. So if there's any questions, that is the end of my presentation. And
that was fascinating. I never knew any of this stuff. How do you go out there and actually if I wanted to get a Google ad to get people into Predict 411, how do I do that? I mean, where's the link?
Sure. You actually just go to Google. Google AdWords is the name of Google's merchant program, and you could sign up right now, and they'll literally be serving ads within an hour of you making your first ad. Google, not only do they provide, absolutely the best user experience as far as the merchant goes, but they also provide Google Analytics completely free of charge to the merchant that has more analytics than you could, possibly, if your full-time job was just diving into the Google Analytics, it would be, you'd still be on overload.
You should, maybe as a follow-up for the next time we do one of these show and tells later in the quarter, I'd love to see something about Google Analytics.
Sure. Yeah, we use Google Analytics as well at my company. Unfortunately, not to the extent that I would like to, but yeah, I could do a presentation on kind of the high levels of Google Analytics, and you could segment, you could funnel, you could slice and dice all sorts of demographics. It's pretty amazing because Google actually spent $100 million developing Google Analytics and then gave it away free of charge because they know that as soon as the merchants start using it, they're going to be hooked and they're going to keep using Google. And it's Google AdWords is actually the lion's share of our advertising online for sure. I mean, Bing and Yahoo do I would say half of what Google does, by itself. So Google just is far and away the winner as far as user interface for the actual merchant and actual, results, considering 87% or something like that of the United States uses Google as opposed to any other search engine.
Impressive. Can I ask you one other question? Then I'm going to have to move you along, and then we'll see if anybody else has questions. What's to stop me from, if I was Google, and let's say you wanted to do something like, if it's paid per click-through, why doesn't Google just hire people to go out there and click on those boxes on the right side of the screen and get people to...
Right. Do like the dummy clicks or the robo clicks, because ultimately it hurts their own reputation, and the merchants lose trust in Google. And in fact, just the opposite of what you said, what Google will do is it routinely analyzes the clicks coming from that people are clicking on your ads, and if it determines that it's a robo clicker or some sort of script or something to that effect, it'll actually refund you for those bogus clicks.
So if I don't like, as a Cleveland Browns guy, if I don't like the Pittsburgh Steelers, I could click on their ads just to hurt them.
Yes, exactly. It might cost them, 50 cents or something like that. So,
hey,
if you guys really want to be mean to me, you can go to that sample ad I had in my PowerPoint, and it'll cost you some money. But
I've hit it 1,000 times already, JD.
I won't do that. So.
So yeah, to answer your question, I mean, the absolute essential part of this kind of three-way relationship between users and the merchants and Google is, Google wants more people to click. The merchants want more people to click, and the merchants have to have that trust in Google that Google's not gonna, basically line their pockets by giving bogus clicks that aren't actually going to lead to any sales. Because part of Google Analytics, you can actually track not just the clicks or the impressions, but you can actually track the conversions as well and the sales, and you can tie it all back to the click-through rate and everything else.
This is impressive. I really hope that you give me some Google Analytics stuff for the next talk.
Sure.
So, John, I'm gonna take the ball away from you and move it along, because we try to keep these short and sweet. But this was fascinating. These are two really good talks tonight.
Sure. I can't really see the screen. Does anybody else have questions? I haven't got back to the actual.
Let's see. I can show the enterprise version of Web Analytics and Adobe Analytics. This is John Okui.
Okay.
But
oh, actually,
that might have been related to the MapReduce stuff from before. But I don't think.
No, that's actually so. No, this is
Yeah.
Jason. So there's only two players in this market, and I mean, not to be cocky because I'm at Adobe, but it's really Adobe and Google Analytics. So there's really only two tools in that market.
Yep, I would agree with Jason on that.
Jason, I'd like to see you talk about the Adobe Analytics as well. That would be two great talks next time around. And it's not and in my mind, I mean, I'm with SAS, and I have no problem with people talking about R, because I think R is a great tool, and you just seeing what's out there is very educational. Just getting a big landscape picture. So I'd love to see that from you too, Jason, if you want to. No pressure, of course.
Yeah, sure. And I can show the predictive stuff, the Web Analytics predictive stuff.
That would be fascinating. Okay, who else wants to talk tonight? We got Jeff. Oh, we got a couple of people volunteering. Oh, Jules, we're going to let you go first because you're the one who took down the system last time, but we're going to give you another shot. How about that? But in fairness to Jules, it wasn't his fault. I think he just happened to be at the wrong place at the wrong time. I think Adobe Connect just bombed. It just died on us.
Okay. Do you guys see my screen here?
We sure do, Jules.
Awesome. Okay, we're ready to go. So what I'm going to be presenting tonight is some basic aggregate and analytical features of SQL, and primarily using the partition by clause in SQL. So it's actually very powerful, and you could actually really do a lot of slicing and dicing in your data. So it's something that I think it would be really good to have under everybody's tool belt. So one of the first things I'm going to do is I just went ahead and created some dummy data here. So I just made up some numbers and some made up data. So one of the things I want you to pay attention here to is the location ID. So notice that, because I mean that's going to become more important as we go through this. So one of the things here is you could actually go ahead and partition your data by that location ID. So when you use this clause right here, over partition by, it actually allows you to go ahead and partition. So notice here, like the location was 100, and it goes 1, 2, 3, 4, and then it starts all over again for location code 101. So it actually allows you to partition that. So the next part of this is actually using aggregate functions right here. So you could actually also use like the sum, the average, standard deviation, the count, the min and max. And what I'm doing here is, again, I'm partitioning this by location ID. So it gives you some general statistics on your data. So it's just pretty powerful things that you could do. So you could also even do like moving averages and cumulative totals here as well too, with this particular technique, where you could actually go ahead and see what the moving average is. So for this example right here, I'm actually doing a partition by the location ID, and I'm ordering by the date. So I'm essentially basically doing a partition by the year right here. So you have a moving average, and you have a cumulative total, and you have a profit year to date. So, and you could also do something called quartiling. And let me illustrate what I'm going to show you here. So essentially, there's this phrase called the end tile. You could actually even do like a 10th tile or 11th tile. In this case, I used 4 because that's what they primarily use in industry. So what it does is it actually kind of like ranks your data, saying, okay, are you in the first quartile, the second quartile, the third quartile, or the fourth quartile? So it gives you a lot of flexibility, and you could also rank in terms of relative to other people within that partition set too. So it allows you to do ranking as well too. And the last thing I wanted to show, a couple of things I wanted to show you guys too, is the percentage. So this is pretty powerful. So in this case right here, you could actually do like a cumulative distribution, a percent rank, and things like that. So, and you could also do essentially what a percent rank is. It actually calculates the relative rank of a row within a group. And a cumulative distribution, it basically represents the percentage of the transactions that have a cost less than or equal to the current transaction. So in this case, I'm actually using cost as my metric, but you could actually use like salary or any other type of metric that you have in your table. And you could also do like continuous distributions, and you could also do medians as well too. So you could actually change this number 50% to 75%, so you could actually see anything less than or equal to that percentage within that median range. That's pretty much it. So I try to go as fast as I can with this. Any questions?
Can I ask you a question? Are these SQL commands that you're using here, are they standard commands that people don't know about, or are they indigenous to some very specific version of SQL?
That's a good question. So what I'm actually using right now is SQL Server, but my understanding is Oracle uses a lot of these functions too. So it may not be exactly the same syntax, but like the major database technologies have very similar functions here that you could use. So I mean, in this case, I just happen to be using SQL Server, which is pretty common in industry.
Is SQL Server sometimes like an open source kind of thing that I could download and use it myself? I hear people talk about it all the time, but I don't really know much about SQL Server in general.
Yeah, actually, what I did is I actually downloaded it for free from the Microsoft website. So if you want, I could go ahead and provide that link for you in the presentation, and I could go ahead and post that information out. And it usually takes about an hour or so to download the entire thing. But yeah, you can definitely get it for free.
That's amazing. If you'd be kind enough, think about even doing that for a later talk. Maybe talk about how to download and install a SQL Server.
Sure, I'll be happy to.
So Hero's asking a question. He says, my SQL Server is a free one, and he's got a question mark. So is that SQL? Or is that?
Yeah, it's SQL Server.
I have a question.
Yeah.
Right. In the resulting of the data, the row num, is that valuable with respect to using it later on to evaluate the columns? I'm sorry, the rows coming out, resulting from the data set.
Yeah, I mean, that's a good question. It doesn't really have a lot of good intrinsic value to it, but it helps you organize your data, per se. So let's say if you want to just see how many general rows you have within a partition, you could actually just quickly gaze there and see it. But in terms of like any type of analytical capabilities, I don't think it really has too much value to it. But I just wanted to demonstrate it as part of the partition statement here within SQL.
Right, and the reason I'm saying that is where I work, there's some old queries that people have, programmers have used this row number, and then they take the row num value and then they divide it by the number of rows in the table, and then they bin it, and they call that some sort of risk value. So I was just wondering, why would anybody use the row number as a numerator in to creating risk scores?
Yeah,
and I think it. Go ahead.
No, go ahead. I'll let you finish your thought.
No, I was just, wondering if there was any other value to the row number than just to order, just to have your rows ordered. And I don't think there is any other value, as you say. It's just to see the ordering of the rows.
Right. Yeah, I don't think it really has too much value to it. It's just that maybe people like to organize their data, per se, and to see how many rows that they have within a partition. So, I mean, that's really the only value I would see with that.
So actually, Sandra, this is Jason. I actually use something like that where when you look at sequenced events like touch points in a path, that row number actually comes in pretty handy in terms of it's the first in the path, the last in the path. For example, marketing touch points or communications, whatever it is, having that as the first and last, like the min-max, that row number becomes very valuable in that partitioned or grouped, those groupings.
So essentially, what you're, Jason, is you're actually using that partition and the row number, and you're just taking the min and the max value from that?
Sometimes, not very often, but once in a while.
Okay. So yeah, I suppose there is certain values to it. I'm sure the designers of SQL will probably want to put it in there if there wasn't.
Right, but then, Jason, your goal would be to see the sequence of your rows. what I've been working with, or what I've been trying to understand is, it's being used as the say a paid amount, right? Instead of actually using the business data of paid amount, the row number of the sequenced paid amount is being used as a denominator. So that's why it would not make sense to me. As a sequence, I can see why you would use it, right? How many rows you have from 1 to 20, and give me the 20th one. But if the 20th row, in your third quartile, or if they're on the first quartile, would not be indicated by the row number. It would be indicated by the actual business amount or metric.
Well, I just have to ask the person who created it. I have no idea.
Okay. Thank you for all the information. This is a great presentation.
Thank you.
I love this show and tell. I'm getting a whole cross section of stuff I know little to nothing about, so I enjoy these. I guess Jules, unless you have any parting thoughts, I'm going to throw you back into with the rest of the rabble and put somebody else in charge.
No, I'm good.
Okay, thank you so very much for doing that.
Oh, you're welcome.
Okay, let's see. I guess we're going to say Scott Lancaster. I'm just going to grab you up by random, but
Sure.
so
Why not?
What are you going to talk about today, Scott?
I'm talking about a lightweight project management tool called Asana, which is a tool you can use on a website. Hang on a second. I'll get the screen share going.
Okay.
Hope it will work.
What's your password I need?
So it's called Asana?
Looks like I have to download something, so it looks like it's downloading that.
Okay, it'll take a second or two. What's it called again? Asana?
Asana, ASANA.com. I never heard of it. I came across it when I was in our first team project in Dr. Miller's data visualization class, and I just stumbled across it because I was looking for a tool to manage our project with our team, and picked it up pretty quickly. So I've been using it on other team projects because it's pretty lightweight. Your meeting has been opened and Adobe Connect added. Okay. Let me open it. Okay. Share my screen. Share. Hopefully you can see this. Okay. Can anybody see it all right?
Yeah, I'll have to make my screen bigger. Okay.
Yeah, I have a pretty high resolution screen, so it probably looks small on your screen, I'm guessing.
Yep, I can see it better by maximizing my screen. So anybody in the audience might want to maximize their display.
I'll try to zoom in too. That might help as well. Let me try that.
Oh, much better.
Okay, cool. All right. So Asana, as I mentioned, is basically a task-based project management tool. So you don't have to be a project manager or a PMP certified. It's basically pretty lightweight. It just basically is, you put task in and you can put some subtask in, and that's pretty much it. And you can assign resources, you can assign dates, you can put notes in, and it's a pretty powerful tool for what it delivers, and it's free, for basic usage. So for like what we do in our class here, you can just go in, sign up, ask for it, and you get free usage to it. So what we're looking at here is on the left-hand side is basically a list of projects in here, and then this one is a capstone for 498 for our class here. This is my team, the Airbnb Team 2. So these are the team members that are in here, which you can add in here basically just by, you want to add another user, you just click on this and you type in their email address and they get access. And that's basically a permission-based use of that. When you first sign up for Asana, you basically create a workspace, which is what we see in the upper right-hand corner, and you can create your profile. So here you can see my picture and any other type of information you want to see within it. Once you create the workspace, you can come down here and create projects. So basically to create a project, you just click on this, type in your new project, and do you want to share it with this particular group, or maybe it's a private one that you want to use. So I'll just use the one we're using in our project as an example, which is our very generic capstone 498. And in here, you can see a list of tasks. And up top here, basically, you can create a new task. You just type it in. If you put a colon at the end of the task, it creates that as a header, and anything below you create would become basically a subheading under each of this. So this is our project goals deliverable, which is due Sunday, and you can see a description of that project, which is basically, a cut and paste from Don's presentation, but it's an easy way to kind of put that information in here so you can quickly look at that. And then we assign owners for each section of that paper that we're creating on. So you can see myself in here, Jules owning the business goals, analysis, Brian and deliverables, John, and then project myself. So when you go in and creating, let's say I wanted to create a new task, all you have to do is click anywhere in here and you hit the enter key, and the next line it will create will be a task. So let's say I want to, create the appendix as a separate deliverable under this deliverable, right? So that's it. You type in and you're done, right? And then you can come back in here, and if you want to add a description to this, you just come right over here and say, here's the description. Away you go. If you want to assign a due date, you can click up here and say, this is due the 24th, and boom. If I want to assign an owner, I can click it here or here on the right. So if I want to assign it to me, I just click me. If you want to assign it to somebody else, you just type in, someone else's name there. And it'll basically pull out the list of users that you assigned to this project. So it's only going to list the 4 people that are in this particular project. A couple other nice features that are part of this is that you can create subtasks. So for example, under analysis, we broke that down. If you look on the right-hand side, you can see it's broken down into data, methods, tools, and models, and preliminary analysis. And each one of those can have its own owner and a due date as well. So basically it has 2 levels. You have the tasks themselves on the left-hand side, and you can create subtasks in the details section here, which can also have their own separate due date and deliverables and stuff. A couple other nice features that I like about this tool that we have used is that you can create links to, let's say, external documents. For example, I can come in here and say create a link just by creating an attachment icon clipboard here, and you can see that we already have a link to our paper. So once you create that, let's say I want to add another one in here. You can attach it from your computer, or if you're using Dropbox or Google Drive or Box, you can use that. So for us, we have a Google Drive, and it's going to automatically go out and know that I have a Google Drive account, and you can set that up, and you go into the folder that you have and select the document you want to attach to it, and that will get attached immediately as a link in here. So for example, our paper that's due this Sunday, we can click on that, and it'll automatically open that up and allow me to start editing it right there if I want to. So that's kind of a cool feature that I like about the tool. Something we didn't use, we're not using this class, but I have used in other projects in the past in this program, is that you can actually create a comment section for each individual task or subtask in here. So if I want to say, hey, hey, this looks good, or, but take a look at the second page or something like that, you can put that comment right in there, and everyone will get notified of that comment, and someone else can come in here and respond to that comment directly. So if someone want to come back and respond to that, it'll get embedded in there. So you can have like a conversation piece on each one of these individual tasks that you want to do. If you want to move something up, you just basically grab it to the left and move it wherever you want it to go. So if you want to swap those 2 lines, you could do that. So again, it's pretty straightforward. As you complete something, you can actually come here and check off something that's being completed. So for example, my introduction is done on this paper, so I can check it off. You'll see it disappear or be completed. Let's say, this is done. Maybe Jules has finished this already. And so you can check these items off as they disappear. And if you want to see the completed tasks, for example, you can actually, there's a filter up here and say, show me all tasks, or, show me my recently completed tasks by date or by, a week or whatever. So I can look at what was completed today. I can go in and see them. So again, from a project management standpoint, if I imagine very small, small type projects like we're doing in these teams that we have at Northwestern, it's a great tool to be able to coordinate and track some of these projects. So you can assign owners, you can assign dates, and everybody knows what's going on here. You can link this up so that you'll get email notifications on these items as well. There's a lot more information, capability, which I don't use in here, but you can kind of go in and have a calendar. You can actually put due dates in the calendar and things like that, which I don't use, but things are, capability in there. The other thing you can do as well is you can create tags. So So if you want to sort and filter by specific tags, you can do that pretty quickly and be able to put that together in there. I think that's basically the basics. Does anyone have any questions? Again, it's fairly straightforward. One thing I did want to show is, you can, if you have multiple projects, multiple teams that are in here, you can actually create separate workspaces for them, like what I did in here. It's like, from the last term we had the leadership class. And what's kind of cool too is you can have multiple projects, and we've done this before where like we had like a brainstorming, and we just put it in a separate project, just a straight list of stuff, and then we assign owners to it, and then kind of put stuff in there and make that separate from your individual project plan. For example, we have another project plan which is based on the CRISP DM methodology, which allows you to basically look at how do I structure a data mining project. From a formal perspective. And in the business leaders course, they actually go through that, and I actually created a project in there that shows that. But basically, you got to go through business understanding, data preparation, modeling, evaluation, deployment, and there's separate subtasks for each one of those that are in there. So you have a lot of capability, and you can also have the ability to export items as well. So if you want to dump this to a CSV file, you can do that. So I'll open up the question now because it sounds like my kids are running around here. So any questions?
Well, this is Don. Of course, I always have good questions. I don't know. I feel like I'm hogging all the bandwidth of the speakers. But here's my question is, so this is completely free, right?
Yes, for what I'm showing here, it's completely free. So anybody can go in here, go right to that website, asana.com. Create a workspace, basically create an account, create a workspace, and away you go. If you want, there's certain capabilities that you have to pay to get. So you see this upgrade up here, and I forget what it is. I think there's like a limited number of users, and there's certain capability that you don't get. It's basically designed if you have an organization like a company, you get more capability and the ability to move projects between the organization and stuff like that, which you don't get in here.
I see. Okay, so it's free, but then to get the upgrades, you get it's like Dropbox. You get more as you start paying for it. And it looks like you're just flying around here with a lot of ease. How long was your ramp up time to learn? This.
Yeah, it was pretty straightforward. I come from a PMP background. I use Microsoft Project and stuff like that. It's so much easier than that. This, we did, like in the couple courses we've done this, I've done like basically a 15 to 20 minute overview of how to use it, and then people started using it. So, I've been in projects where each team member goes in and manages their own tasks, other projects where I just manage the task for them. But they actually have some pretty good tutorials as well as content you can look at to kind of show how to do the basics. But usually I'd say I was basically up and running with most of the functionality within like a half an hour. And then anything else I wanted to learn, I just looked up as I went. But if you just want to go in, like when you create a new project, it's all you have to do is you just start typing. So if I started like new project, right, and put it in here, you're done, right? Your project is created, and the owner is already automatically part of the workspace that you're in once that's set up, and setting up the workspace is just as easy. That's it. Here's my task. I got a blank sheet, so I just say, task 1, task 2, task 3, right? And you just type them in. And if you want to make this a header, you put a colon there, and it becomes a header. And then if you want, then it's up to you. If you want to add more detail, you can. If you don't have to. So you can just do a straight task list in minutes. You're done. And then if you want to start assigning owners or due dates, any one of these items, just say, here's the due date. This task is due next Friday. Boom, and it's going to be owned by, it could be me, or say I'll assign this from the JD. He's going to do this task. Boom. That's it. That takes care of that task. So it's pretty straightforward, and you can flip between projects just by clicking in here.
Okay, one last question, then I'll move it along. So for your Predict 498, would you recommend this for future classes? So in other words, if you were to put a message in a bottle, for like I do with my classes, would you tell them that this is a good thing? Or, has this, obviously it's working for you guys, but do you think this would make generic sense for other 498 groups?
Yeah, no, I recommend it for any team project within Northwestern. I've used it in 1, 2, 3, I think it's the 4th or 5th one that I've used it within. And depending on the team, some are more active than others, but I would definitely recommend it if you want just a very simple task management list where you can keep, straight list of items, be able to assign owners and dates, and quickly be able to just manage that list. I mean, obviously you could do this in Excel, you could do this in a Word. You don't need something this fancy, but I like it because all the team members come in here at the same time, work on this together. Like in some of the projects I were in, we actually were brainstorming live, and each type in different brainstorm ideas in here as specific lists. And then we organized it, and then we assigned owners, and we did it. So, it kind of depends on the project and how many people you have, but, teams of 3, 4, or 5, it works really great.
Wonderful. Okay. Well, I don't have any other questions. Anybody else in the home audience have a question? Okay. Well, who else wants to do a talk tonight? Okay, we got Jeff Hoiberts next. So let's see. Jeff, I'm going to make you the presenter.
Okay.
Thank you so much. Scott, thank you so much for doing that.
Oh, you're welcome.
Okay, Jeff, all you have to do is share your screen.
Okay. Sorry, I've got to go through the install as well. Can people hear me okay?
Yep, I hear you fine.
All right. It's like connecting Adobe. I'm going to be talking about the IBM Watson question answer system.
Oh man, this is going to be great.
All right. And can people see okay?
I sure can.
Okay. Just to level set, the piece that I'm going to be talking about is IBM Watson question answer system. There is another category of the IBM Watson analytics that people might have run across that tends to be more of the just text analytics visualization side of the tooling. So this is more of the original Watson system that competed on Jeopardy. So really just focused around the answering of incoming questions. So for background, it's the question answer system, slightly different take than your traditional search engine system, where search engine system you're primarily focusing on keyword searches and trying to come up with relevant results based on that. In the question answer system, there's really meant to be a more in-depth analysis and understanding of the question and contextual information that's coming in, providing potential answers and the evidence of how the system came up with those answers, and then being able to return confidence scores along with those set of answers. So the kind of high-level architecture for the Watson system is starting on the left on the blue question icon. Question will come into the system. There'll be some initial inquiry and analysis about the question, trying to gather up some contextual information so that it just garner a better understanding of the question as a whole as it comes to the system. So you'll get some NLP over that. At a certain point, it will move on to the decomposition, where it takes the context and kind of boils down the context to find the atomic pieces of relevance so that it can go forward. And at that point, it will move on to, in these charts, and excuse the charts, I stole them from marketing, the hypothesis generation. You can think of this as, okay, the questions come in, we've done some NLP on it, and at that point it goes out to a corpus that's been ingested specifically for the system, and this would be, this corpus for the original Watson Jeopardy application, that corpus was Wikipedia. For medical applications, that corpus contains all the medical journals, articles, so forth. Those are all ingested. The candidate answer generation will go out searching those for answers to the question, pieces within the articles that are relevant, come back with some number of candidate answers, and then move on to the next step. And that's where this hypothesis and evidence scoring comes in. At that point, all of these answers are farmed out in a parallel and massively distributed environment, and in different threads or processes or even different systems. It will analyze those candidates to the question, trying to break them down and give some insight as far as how they should be scored against each other. And I'll get into that in the next couple slides. Once it's scored each one of those candidate answers, it will move into kind of this last step. It's listed as machine learning. At that point, it's taking all the answers and using information about how the scores are coming out with different contexts, and based on the different algorithms that are going into the scoring, it will rank all those answers against each other and modify the scores along with that. So ultimately, you'll end up with a set of answers with the confidences in a set order. And depending on the application, you may just want the top one, or other applications like our clinical trial matching application, it may be completely relevant to have hundreds of perfectly good answers coming out of the system that the end user would be evaluating as well. I guess going back into the scoring side, in a very simple case, you could imagine, okay, the question coming in, and this is kind of the traditional Jeopardy type question. In May 1898, Portugal celebrated 400th anniversary of explorers' arrival in India. It reaches into the ingested Wikipedia information and finds a passage. In May, Gary arrived in India after he celebrated his anniversary in Portugal. If you're just doing simple keyword matching for both of those, it may say, oh, I matched up 90% of my words. Gary must be the explorer, and would come back with an answer based on that. Well, that's just using a single algorithm that doesn't have very much understanding of how the text, how the terms are related to each other, and just doesn't provide a whole lot of use. You get enough of those algorithms built up together, and you're able to score the passages in multiple ways, and ultimately find the context or linkages between the terms, so that you could come back with a different passage that is structurally matching the incoming question. So in this case, you'd come back with Vasco da Gama, and the confidence, you still may not have a 100% confidence based on all of these algorithms working, but you would that would hopefully score better than the Gary case. In the kind of very end of it, the machine learning case, this is where for each application, you don't just have a single Watson application that's taking all of the questions. You try to tailor it to a particular environment. And for instance, Watson in healthcare, we're taking the ground truth of particular applications and trying to get it to learn that the contextual information for, say, that nurses may be bringing to the system and expecting it to be aware of that context, that is picked up in how it would be interpreting the different scores coming out of the algorithms. So you need the ground truth to be able to do that. In the set of kind of Watson advisor systems, this is where the engagement advisor system is kind of your traditional Watson question and answer being applied to environments like call centers or places where there's some dialoguing occurring, or cases where, imagine applying it to a business that has lots of manuals and people being able to ask questions and have it respond based on the ingested manual documentation, being able to interface with the system in that type of environment. Discovery and exploration is the application of, okay, when it ingests all of that corpus and information, the entity relationships that it generates amongst all of that, all of those articles and documentation, it can turn around and provide visualizations and cues to people to be able to explore just the ingested data itself. For instance, I think it was the University of Tulane was looking for protein chains, and short of having someone go out and read all the articles and keep up to date, they discovering the new relationships was made much easier by being able to say, okay, protein chain 1, protein chain 2, they're found in 5 articles out of 5 million, and they're found in relationship to protein 3, so we should investigate protein 3 as well. And then Decision Advisor, that's the one that I typically have been working with, is the case where Watson is ingesting policies or procedures or clinical trials, things that have explicit criteria that need to be met or not met, and taking patient data or customer data and applying it to those policies, procedures, and so forth, and saying whether or not they're eligible for those. Our first use case was with an insurance company, excuse me, insurance company looking at those, looking to see if patients were eligible for specific procedures. Another use case is clinical trials. Doctors being able to find open clinical trials that their patients are eligible for based on medical conditions. And then the entire Watson infrastructure is being made available to third-party coders, business partners via IBM Bluemix, which is taking a lot of the users, turning them into services so that end users can pay per usage or some licensing agreement for particular pieces of the pipeline. And moving forward, kind of moving beyond just text analytics, you'll see the speech to text, and then the Alchemy API is an additional product set that were brought in for visualization. So trying to push in different directions for interactions.
Can I ask a question, Jeff? Well, we actually had 2 questions from Hero. He was asking, is this a GUI interface or is it coding based? And his second question is, how popular is Watson in the medical industry?
In the medical industry, I guess we've got a number of different engagements. The ones that have gained the most traction to date are with Memorial Sloan Kettering in New York, specifically looking for oncology patient records and trying to provide oncology treatment plans, and I haven't been too tied with that. the other one that I'm heavily involved with in the medical field was clinical trial matching, specifically providing the ability for the doctors to be able to find a clinical trial. So it's this has all been around for, I want to say, about 4 years, and it's I guess slow in the medical field building up those relationships, but there's, I guess, from the inside, there's no shortage of interest and communications with a lot of the major hospitals. And
the second question was, is it coding-based or GUI-based?
Is the application itself?
Yeah.
The application is, I mean, it's primarily Java-based, but there's UI interfaces built on top of it for the specific applications. For instance, the engagement advisor, kind of that chat processing or the dialoguing has one set of UIs. The clinical trial matching has a different set of UIs.
And one other question here, is there any way of using it free, like in academia, or I'm assuming it costs a lot for a company, but is there like a academic discount or free use?
The Bluemix has some capabilities to try it out, and I haven't explored them a whole lot, but I know you can set up sample applications to be able to call off to the kind of the end ranking of questions, and you can train up question answer systems now. I don't know at what point or what threshold enough questions start coming through it that it triggers some flag saying, okay, you need to upsell into a licensing agreement. But in the IBM Bluemix, they've got a fair amount out there, I believe.
Could you put that, I hope you would be willing to share your slides with us, and then the other question is, if you put the link to this Bluemix, that would be very helpful.
Yep.
Just email them to me, and I'll shove them all together. Let's see. I'm getting, so I guess.
Okay, there, I question.
Oh, go ahead.
Oh, sorry, I couldn't figure out how to get back to seeing the chat.
Okay. Hey, just stop sharing your screen. Can you see the chat now?
Yep, I can see it.
So, I'm gonna take away the control from you, Jeff, and you answer questions while I make the next person the presenter. Who else would like to be a presenter tonight? Okay, Vib or Bata, I'm going to make you the presenter.
Thank you. Let me try to share. Okay. I think I need some help how to set this up. I just do share my screen.
Yes, do that, and then it should give you an option to, then it might ask you to install some software.
Yes.
Is it letting you do it?
I think it's asking me to change some Safari settings, which
maybe you might need a different browser.
okay. Can somebody else go in the meanwhile? I'll have to come back in through another browser.
Let's see if anybody else can go here. Okay, Sandra needs to drop off. But you can give your try again. We'll have another one of these, Sandra. So you can present then. She wasn't ready. She was been up since 5 tonight, 5 in the morning. So Vibhor Bhatta, but let's try one more time to see if we can let you do it. But if not, I think we're done for the evening. I don't think anybody else is going to present. But if let's give you one more try, Vibhor Bhatta.
Okay, I am kind of coming through Firefox. Let me try.
Okay.
Okay, this seems better. Install the plugin. Okay, can you see my screen?
Not yet. You'll need to share your screen.
Once your plugin is downloaded, there's an app that's running behind it. Just minimize that, and you'll see the app and share again.
Oh, there. I think it looks like it's loading.
Okay, can you see my screen now?
Yeah, I can see your screen now.
Okay, great. So again, thank you for the opportunity today. So what I'm going to do today is use a library called Labs to do a simple regression analysis in Python. Again, I'm early into the program. This is my 4th course, so maybe it's pretty simple for the rest of the audience here. But just wanted to use Python packages to do a simple regression analysis. So what I have on the screen is an IPython notebook called Jupyter. A notebook is kind of a very easy interactive interface for programming in Python or in R or in other languages. So very interactive, and you can get in your data, your visuals, everything, and then you can kind of take this and as an application and give it to your business users or end users or your team members to continue the process. So what I'm going to do here in this empty notebook is import that package called GraphLab. And this is an open source application for programming and interfacing with through Python or through other applications. So next step would be to import that data set. So this is the data set is like we did the MS home price application in I think 4.10. I'm going to use a similar data set to do a simple regression analysis using Python. So I'm going to call this package GraphLab and create similar to our data frame. In this, they call it S frame. So I think it's called home data. So give me a second.
Is this set on your PC?
No, in fact, I'm using a cluster on Amazon Web Service.
Oh, okay.
But I could install it on my desktop as well.
Okay.
To make it work. Yeah.
Okay.
I got the data loaded. Let's do a little bit of analysis of the data. So very simply, I can use, I want to look at the top few columns of my data set. So these are the fields in my data set. So obviously we're predicting the price. We got bedrooms, bathrooms, square feet, living, basements, etc., year of construction, etc. I can continue to do my analysis. For example, I want to look at the mean price of my houses in this area. This is a small township in Seattle of which we got the data set. So simply do mean, and I should be able to see an average price of this household. So typically I'm using a Python command to interact with the data. I can do some visualization. So typically when I do a show, it goes into another, it opens another HTML, but I will try to have it all within this container. So I'm going to just set the canvas to be this page. So the IPY is typically what is a Python notebook called. So from now, if I do sales.show, it's going to show me mean kind of the averages, some visual of the data. So here we go. So I guess I didn't need IDs and dates, but look at the prices, the bedrooms. Let me just do for the price. What are the key statistics about my data set? So here I got the min, max, the mean, and kind of typical ranges of my data. What I'm going to do next is kind of break my data set into a training and test data set. So simply I can do train and test, which are my two data sets, equal to sales, which was my original data set, and I do random split of 80, 20, and use my seed as 1. So I created two data sets. Let's quickly check our train data set. So train dot head again, give me 5 rows. It's kind of a similar structure as my sales data set. So what I'm going to do now is quickly create a regression model. So my model, again, I call it just model, equal to graph lab linear. If I do tab here, there are many other packages or machine learning algorithms available in here, like logistic, like classification, like clustering, and many others. So a lot of the stuff we typically do programming with our pre-built packages within the system. So let me quickly create a linear regression model, create. My data set is train, and my target variable is price. And the features that I'm going to use for my analysis, I'll quickly create a list, a Python list. So let's use square feet, living, maybe bathrooms, and maybe one more, so bedrooms. And one more kind of parameter that I need to add is if I need to create a validation set out of this, which I do not want to, so I quickly do validation set equal to none. Okay. I guess I needed to provide codes here. So here is my regression model. It calculated the root mean square error, my MSEs, as well as I can look at my my coefficients. So if I do model coefficients, I can look at the my intercept, my betas for the 3 variables that I included in this data set. So now I got this model ready. Now I can very easily start predicting the predicted prices. So in my next step, I'm going to just use model.predict, as easy as this, and use my train data, my test data set. So here we go. Now I've already predicted the prices of my my test data set. What I can do now is calculate the error, which is my which was the price from my test data set, actual price, minus my prediction. In fact, I should have called this prediction. Let me do it one more time. So prediction is equal to that. And so my test minus my prediction, and if I do square it, this is my squared error, and I can do my residual sum of squares by just summing up all my squared differences, and quickly print it. So again, within I guess 5 minutes, or I don't know, maybe have taken 10 minutes. In this kind of open source library, I can take my data set, do my EDA, do my linear regression or logistic or other, and quickly kind of do the prediction of my test scores for comparing my prediction to my target. So that's what I wanted to kind of quickly show this open source library to do that for you. Hope this is useful.
Vipur, we had a question from Jules, and I have a similar question, but mine's, my question is, first of all, is this an add-on to Python, or is this a tool in and of itself? I'm a little confused on that aspect.
So this is a tool in itself called GraphLab.
Okay, so because you had mentioned Python earlier, and I wasn't sure where Python was fitting into this.
So this uses the capabilities of Python. The programming language to interface with that package is Python. So
I see.
All that I'm doing
Python
is kind of writing.
Go ahead.
Go ahead, please.
Okay, so I was just simply saying that. So this package here is a tool written in Python, but it's a tool in and of itself. Is that a correct statement?
That's right.
So Jules Grossi was asking, how do you get access to this?
So I can provide a link, but if you go to a website called dato, DATO.com, they can, so you can download it from there as well.
And so
you can just go right to the Jupyter.org site as well.
Well, Jupyter is just a Python notebook, right? Jupyter
okay,
is just,
but they talk about different languages and stuff on there, so.
So Jupyter is this notebook which allows me to interactively do the work that I'm doing instead of writing my whole code and then batching it up and then running it that way. Everything I'm doing, I'm kind of doing very interactively. So that's a very easy way of learning and doing programming, as well as interacting with data using notebooks.
So is this thing called Jupyter, or is this thing called, now I'm confused again, I'm so sorry.
So the Jupyter is this notebook or this web browser interface that I'm using to interact with GraphLab.
Okay, I'm so sorry. Sometimes I don't get it, so it now makes sense. And so let me think here. Hero had one or two other questions here. He was saying Python has MATLAB capability by installing packages. I didn't know that. MATLAB is pricey, but Python is free. And Jules Grossi was also saying, can you use R in this tool as well? So do you know if you can use R in this tool?
So Jupyter is focused just for Python, but there are other notebooks like Zeppelin, which allows you to write code in other languages as well. So this Jupyter here is primarily for Python notebooks. But yes, there are other notebooks which allow you similar experience with R and Scala and other languages.
Okay. Well, thank you very much. Does anybody else have any questions for the night, or we can adjourn? We got Hero typing another question here. Did anyone present Azure? I had a student present on Azure about a year ago, but you can always do it again. You know, there's no reason somebody else can't do it because you'll have a different take on it. So, yeah, go right ahead, Hero, and we're going to do another show and tell later in the quarter. I'd love it if you did it on Azure. That would be wonderful. So, okay, I guess we are done for the night unless anybody has any final questions. If not, I'll post the link to this tonight or tomorrow.
This is Scott. Just a quick comment. I was just looking at that Jupyter website. It looks like if you use the try in your browser button, you can actually select the language of choice, including R. So I'll play around with that, but that looks pretty promising too.
That's interesting. It's jupyter.com or .org?
.org. You go right out there, and then you just click on in browse, play around in browser, and I'm looking at some R code right now. It looks like it does something similar, so that's kind of cool.
Well, that's fascinating. We still got a few more people typing here. Well, you know what, Jules, I agree with you. I'm really happy with the variety of different topics tonight. I love these show and tells because it just sits there and it's a real quick way for somebody like me to keep on top of the developments because students talk about so many different things that you know, I go back to work on Monday and I'm like an expert on everything, and it's just because I listen to these 10-minute sessions, and I really highly recommend students, when you have time, go watch the recordings of other sessions because there's all sorts of different things people talk about, and it's fascinating stuff. So anyways, hey, listen, guys, I'm going to stop recording now.